Hi, this is Sung and I'm your online maths mentor. In the last episode, we started off looking at permutations and combinations. I generally just gave you a definition of what a permutation is and what a combination is, just so that, you know, by dipping our toes into the water, we can get a feel for what this topic is really all about. Now what I want to do is spend the next couple of episodes laying the foundation, right? Laying the foundation for how to calculate permutations and combinations. We're going to start with permutations then, okay? And the first foundation that I want to lay with you is a principle called the multiplication principle. Now, do you remember what a permutation was? A permutation is simply just an arrangement of a set. It's the number of ways where a set of elements can be arranged, right, from a bigger set. And the key thing with the arrangement is that order, right, order will matter. So in other words, the position of each element within that set is going to make a difference to how many arrangements there are for a set of elements, okay? All right, cool. So with that said, let's have a look at the multiplication principle and what it says, right? Because this is going to really help us to calculate the number of arrangements there are for a particular set, okay? And the multiplication principle says this. It states that if one choice can be made in m different ways, and another choice can be made in n different ways. Now, m and m just stand are pronumerals that stand in place of different numbers, right? So if you've got m ways of making one choice and n ways of making another choice, then if you were to make both choices simultaneously, the number of ways that you can make both choices will be m times n. What you do is you take these two values and you multiply them together, and that will be the number of ways that you can make both choices. Got it? All right. So how does that work in practice? I've got a question for you, and we're going to use this question to see how this multiplication principle works and how it plays out in a practical example. All right, so here's my example. Using the letters of the word math, M-A-T-H, right, which is the American way of saying what we call maths or mathematics, how many four-letter words can you make, or how many four-letter words can you make if, number one, you can repeat the letters, and number two, if you cannot repeat the letters. Okay, so there's no repetition of letters. All right, so we're going to look at two different examples, one where you can repeat the letters and another where you can't. All right, and I'm going to do part one over on the left side of the board, I'm going to do part two over on the right. All right, so let's have a look at part one first. So part one's over here where you can repeat the letters. So how many letters are there? There's four, isn't there? 1, 2, 3, 4. There's four letters. Okay, so what I'm going to do is I'm going to take these four letters and write them over here. Now, what we want to do is we want to create a four-letter word. Not just one four-letter word, we want to see how many four-letter words we can create, right? Which means that we've got four blank positions within that four-letter word, right? All right, cool. Now, you've got, this is position 1, this is position 2, this is position 3, this is position 4. Each of those positions will be filled by a letter, and when you put those letters together, it will make one complete arrangement. Does that make sense? All right. So, for the first position here, how many choices can you place in this first position? All right, well, we've got four letters, 1, 2, 3, 4. So we can actually fit four letters in this first position. Do you see that? All right, so you've got the letter M, you've got the letter A, you've got the letter T, and you've got the letter H, right? So it's 1, 2, 3, 4. So really, you've got four choices that you can put in position 1. All right, have I lost you? Hopefully not, okay? Now, if we can repeat the letters, in other words, if we've chosen the letter M for the first position, can we now choose the letter M for the second position? Well, if we're saying that we can repeat the letters, then the answer is yes. All right? So we can use the letter M again. All right? If that's the case, how many choices can we make for position 2? Well, for position 2, you can also make 4 choices. Yes? Hopefully I'm not losing you guys here. So you've got 4 choices there. Got it? How many choices can we put in position 3? I think you're probably getting the idea, right? So without laboring the point, you've got 4 choices that you can put into position 3, and you've got 4 choices that you can put into position 4, okay? And they are the letters M, A, T, H. M, A, T, H. Got it? 1, 2, 3. All right, cool. So you got 4 possible choices to make for position 1, 4 possible choices to make for position 2, 4 possible choices that you can make for position 3, and 4 possible choices that you can make for position 4. Okay, good. Now, let's go over to the other side without calculating this, because I'll come back and come back to this, right? But let's go over here. This time we're going to do the exact same thing, but we're going to do part 2. We're going to not repeat the letters, okay? So again, we've got 4 positions, right? Now, for position 1, you will have a possible 4 choices that you can select from. Does that make sense? All right, so what number goes here? How many choices can go into position 1? The answer is 4. Got it? How many choices or how many selections can you make for position 2? Now, if we've chosen M for position 1, you'll only have 3 choices left, the A, T, and the H. If you choose A for position 1, you will still only have 3 choices left, but it'll be a different 3 choices. It'll be the letters M, T, and H. Does that make sense? If you choose T for the first position, you'll have 3 choices, M, A, and H. And if you choose H, you'll have the first 3 letters to choose from. Either way, or any which way you look at it, instead of having 4 choices, right? If you can't repeat, if you're restricted by the condition that you cannot repeat letters, any way you look at it, you will only have a possible 3 choices that you can make for position number 2, right? How many choices will there be for position number 3? Well, if you eliminate 2 choices from MATH from the 4 that we had, 1 choice for the first position, another choice for the second position, you've only got 2 choices left, right? The combination of 2 choices will vary, but you've really only got 2 choices left. Does that make sense? And then finally, at the end, you've only got 1 choice left. Got it? All right, so you've got 3 choices, 2 choices, and 1 choice. Right, now, how do you work out then the number of arrangements that there will be for 4-letter words by rearranging the letters in MATH, right? How do you work, where do you go from here? This is where the multiplication principle comes in. The multiplication principle basically says with each of these 4 choices, right, you multiply the number of options for each position along the way, and you end up with, all right, 4 times 4 times 4 times 4. Rather than putting it into a calculator and working it out, what's more important than anything else is the fact that it's going to be 4, which is the number of choices, to the power of 4, which is, the number of positions, 4, which is the number of positions, to the power, let me start again. 4, which is the number of choices for each position, to the power of 4, which is the number of positions. Does that make sense? All right, cool. So you end up with 4 to the power of 4, okay? Over on this side, what you end up with by using the multiplication principle is you end up with a expression that looks like this: 4 times 3 times 2 times 1. So in other words, what you're doing is you're multiplying the number of choices that you have for the first position by a number which is 1 less each time until you get down to nothing. Does that make sense? So 4 times 3 times 2 times 1, because 3 is 1 less than 4, 2 is 1 less than 3, 1 is 1 less than 2. Good. All right. Now, here is where we can draw some principles from all of this, right? When you've got arrangements with repetitions, basically the number of ways that you can make arrangements with n repetitions is going to be n to the power of k, okay? Whereas if you've got the number of arrangements, where you need to calculate the number of arrangements without repetition, it's going to be n, and here's something new for you, with a little exclamation mark, right? And that little exclamation mark stands for the word factorial. Factorial. And what factorial means is basically you're multiplying by every single number before it, okay? So let me just put a little box around that. All right, so n stands for the number of choices per position, and k stands for the number of positions, all right? So it's n to the power of k will be the number of arrangements that you have. Whereas here, for the number of arrangements without repetition, is n, which is the number of choices per position. Got it? Cool. All right, so in the next episode, I'm gonna talk a little bit more about factorial, okay, and how it works. But basically, if you get these two things, and you get the multiplication principle, right? You've got enough of what you need for us to really launch into permutations and combinations and to be able to do all the problems there. Thank you very much for watching. I know it was a long episode and I thank you for your patience. Bye.